everybody.
Hey Newman, you there?
Oh, God, I thought I froze.
Oh, Jesus, Newman, you dropped off. So maybe I'll
Oh,
do the introduction. Hey everyone, we are back with Community Code Review where we go through Aiken language for building smart contracts on Cardano. Currently, we are going through the Aiken project-based learning course hosted by the Andamio platform. And this is the Andamio platform right here. In the last week's session, we went through module 101 and we have completed it. And today we'll be going through module 102. How are you guys feeling, Newman and Lewis? Are you guys ready for this?
Super excited. You know, anything to do with Andamio V2 gets me really excited. It
Very
looks really nice
nice.
also. Right, don't you
so,
Oh,
think?
wait, the lesson not found. What is this?
What?
um,
Oh,
Oh, maybe they haven't migrated it. Maybe we have to go to Andamio
V
V1,
1.5.
maybe.
which is unfortunate, but we'll get that done. Um, Enter app, go to V2 is live. No, I think we'll stick to V1. Uh, no, we'll go to the courses. Aiken. We got through getting started with Aiken. Writing your first smart contract. I think this is the one. Okay. I wonder, okay. Updated for Conway error. Writing your first smart contract. This is what the module says. Updated for Conway era plus Aiken release. This is such a random thing to start off with. Okay. You're taking this course at the right time. Aiken 1.1 was recently released, and with it, some changes to how Aiken works. This course is up to date for the current version of Aiken and for the compilation of Plutus V3. Very nice. Okay.
Mm,
In this module, you
mm,
will start to learn how validators work. We will build up a definition for validators as we go. Spending validators. A spending validator allows you to write custom logic for how tokens can be unlocked from a Cardano address. Okay, so it helps us unlock UTXOs from a specific Cardano address. Minting validators. A minting validator allows you to write custom logic for how new tokens can be minted on Cardano. Okay. And other validator types. There are also other validator types for staking and governance transactions in this course. We will focus on spending and minting validators. Okay. I think they're saying they'll focus on
okay.
spending and minting. But are you guys clear on what spending and minting validators are? Does that make sense? Um,
Yeah.
yep.
Hey,
Okay.
it's Newman. Can you guys hear me?
Yes, yes, we can hear you.
Yes, we can
Okay, okay.
finally.
Yeah, something happened.
All right.
Yeah, it's
Okay.
interesting. Like
Mm-hmm.
spinning a validator allows you to write custom logic for how tokens can be unlocked. Yeah. We'll get into this, but yeah, this I feel pretty good. It's important to read these first intros to the sections.
Yeah,
Um,
yeah.
but I feel like we can go to the first SLT,
All right.
which is
So the first SLT is I can write and always succeeds spending validator.
yeah,
First spending validator. Aiken project structure. In an Aiken project, all validator code should be written in the validators directory. So we have cloned the directory from last time, from last week's class. And this is how the directory looks.
Yeah.
And there should be a validators um, directory, sorry, folder here. And in this folder, we can start putting our validators. And here you can see all the validators here.
Yeah.
Oh,
Okay.
And I wonder if
Mm-hmm.
you, what's this isn't a part of the course, but I wonder what that first, like, there's like an npm Aiken init thing. Um,
in it?
I don't think it's
yeah.
npm Aiken in it. I think it's Aiken new or something like that. Uh,
Hold on, let's
y-
put Aiken help.
no, so it's directly there on the Aiken docs. So when you first
Oh,
start,
Aiken new. It's Aiken
yeah,
new.
Aiken new. That's what I said. Yeah,
But let's see. Yeah, it says
here, where
just
is it?
for if we're talking about like structure, and then we may be able to do it. So once this is installing it, go to the next one, like getting
Getting
started, maybe.
started. Yeah. So feel like there should be a
Create a
command.
new. It's
So
right there, right there. No, one more, right there.
here it is. Here it is.
Aiken
Aiken
new, and
new.
Is it Uba?
Foo is like the
I think
folder.
everybody did it.
Foo is the folder, right? Like where is foo here?
yeah, but it looks
So
like
foo
I'm
is
gonna,
the root folder, I think. Or
yeah.
maybe foo, no, foo is actually
It's a
like
hello
the,
world.
yeah, so it's like the developer name or something like that.
Yeah.
Okay. So
So
we have that.
I can name.
Okay, so that's how you start it, and you put, okay, without getting deviated,
Ha ha
in
ha
the
ha. I was trying to
Aiken
deviate you.
project, all validator code should be written in the validators directory. But here, I'm just curious, and I'm going to ask you guys a question. Here, I see multiple directories, right? There is a homework directory, there's a library folder, and a module folder, and all of those have Aiken code in them, right?
Yeah.
All of them, maybe except for this. This doesn't have any Aiken code in it, but this has Aiken code in it. So, how can this Aiken
Oh,
code be here? What's the difference
the
between this code that is in the validators and this code?
well,
Do you guys think?
I was looking at it earlier, and I was like looking at one of those P2s, those P1s.
Mm-hmm.
Uh, notice that they only have tests and functions in there. There's a
Yeah.
function.
Yes.
So, and I don't understand why you wouldn't have it as just a P, I guess, so that you can, why wouldn't you just have it as a TypeScript file or some other thing? I guess it's so that it's visible to the whole Aiken verse, uh, maybe.
Uh, yeah. So,
I don't know why you would have like little library stuff, little helper functions. I
like,
guess, yeah,
I mean, because you can import those functions, right? Like
I
just
guess
like
that's
any
it.
other programming thing,
Yeah.
right? Uh, but all the validators. So for example, you're right. All the functions are here,
Hmm.
but all the validators are here. So all of these should have a validator in them. So is this a validator? Let's see. One second. Let me close this guy. Is this a validator? I don't see a validator here. Oh,
Uh,
now I get it. So all validators should be in the validators folder, but
Yeah.
not everything in the validators folder is a validator. Does it make sense?
hmm.
Uh,
Because this is not a validator. I don't see a validator in this. See this?
Uh, I guess you're right. It's just a
Just S.
interest. Well, it's functions that create transactions.
Yeah, I mean, just like, yeah, just
Well, let's
functions
scroll
and
down. So
tests.
there's yeah, functions. So like there's that function mock test. And now one thing that's important to know if anybody's listening to this video, uh, that in these they're basically doing it in two different ways. They're using the mocktail library and sort of without the mocktail library. So it's two different.
I feel like people that are watching this,
Yeah.
if they watch like our last episode, I don't think they know what a mocktail library is at this point.
Oh,
Uh,
okay. Well, we'll definitely go through it. It's slight, yeah. It's
no, no, no.
something
Let's
that,
not go into those details because those are like slightly
yeah,
higher level details. We'll go to
yeah,
the basics and then we'll jump
Thank
in
you.
during
Thank
the
you.
testing. Okay.
yeah. Okay. All right.
So now we know that all the validators will be in the validators folder, but not all files in the validator folder are validators. Okay. So we are clear until there. What does it say? To view the example code for this lesson, open the validators directory, open the module 102 subdirectory, open the validator
Mm-hmm.
always succeeds spend.ak. All right, so
Okay.
let's do that. So
Let's go.
I'm
Let's
gonna close
go.
this. Oh, validators directory module 102, and which one did they say? Always succeeds. Always succeeds
Always
spend, they
succeeds at
said.
AK.
Yeah,
Spend.
yeah,
The spend in this mint, yeah? Yeah.
yes. 1 second. I'm just gonna close this. So okay, so we have this open. What are they saying? Aiken validator structure. Here is the code for our first validator. Okay, so they just are repeating the code. Things to notice: lines 1 to 3 are important statements. Some of these imports output reference are used in the validator code. Other imports are used in the tests below. Okay, so
Mm.
basically they are saying some of these imports are used directly inside the validator and the other imports are used inside the tests. Do you want to quickly see what imports are used in the validator? Let's see. I don't see a mint in the validator. I don't see a script context in the validator. What is even used in the validator? Output reference maybe? Yes, output reference is used in the validator.
Oh,
Transaction is used in the validator, and the placeholder is used in the test, I guess. So placeholder is used in the test. Mock UTXO
Wait,
reference is used in the
minting is
test.
not used?
What is it?
Minting.
Minting is used here, right here. So everything is
Oh.
used.
So, yeah, everything is used then. Every
Yeah.
script context. Oh.
Yeah. So that means this is the import section. This is the validator section. And after the validators, they have a test section.
yep.
Okay.
Okay.
And like Newman said, there is no specific hierarchy. These tests can go above the validator as well. And we have tried that in
Yeah,
the
figured
last
that out.
session. Yeah.
So wait, say that again. They can go above the what?
So these tests, you can cut them and paste them above the validator as well, right below the
Oh, okay,
imports.
okay.
Yeah.
Yeah,
So
it'll still work.
In between, yeah. Okay, so
Yeah. Lines one through three. Oh my God, one to three are import statements. Okay, we have already figured that out. Line 9 is the signature of the validator. Let's see what is line 9. I mean, I'm guessing this is what
yeah,
they
line
mean.
10.
Line
Yeah.
10, yeah. Line 10 is the signature of the validator. Okay. What does the signature say? Line 10 is the line 9 is the
purpose.
signature of the validator. The validator keyword is used followed by the name of the validator. Okay, so the validator keyword is used followed by the name of the validator, which is always succeeds. Um, in this case, we are writing a validator called always succeeds because it will always succeed. Fair enough.
Mm-hmm.
Line, line 10 is the purpose of the validator. In this case, we are writing a spending validator. Every validator type accepts a different set of parameters. On lines 11 through 14, you can see the parameters for the spending validator. It's right here, and in our this thing, it is right here. The spending validator takes these parameters. And one thing to remember is that it always takes the exact same parameters. datum, redeemer, input, and transaction, and it takes it in exactly that order. Datum, redeemer, input, and transaction, the same order.
And those
Um,
are the parameters. It's same params in the same order.
yes, yes. The only thing that can change is that we can make them optional or not optional. So the
Right.
underscore in front of these parameters makes them optional, but we still have to keep them in there. And what does that being optional means? We'll explore that later.
Yeah.
Um, okay. Line 16 is the return value of the validator. A validator should always return a boolean true or false. Okay. If the validator returns true, then it will allow a transaction to be built. Okay. So on line 24, this is what they're referring to. This
Yeah.
validator always returns true. That means this validator will always allow the transaction to pass. And that is why it is called always succeeds.
Hmm.
Uh,
Hmm.
if it returns false, it will not validate the
Oh no.
transaction. This is a very simple validator. It simply returns true, which means that it will allow any transaction to spend from it. Sometimes you will define parameters without using them. In this case, our validator returns true no matter what the value of the datum. No matter what the value of the datum, redeemer, input, and transaction. That is why all these parameter names start with underscore, because it doesn't
Yeah.
matter. That's literally what the underscore means. That means they are not used anywhere inside of the validator, but they still should exist in the exact same order, just like this. Um, the underscore tells Aiken to ignore these variables. Try removing the underscore and run Aiken check. Let's try that. I'll just remove one underscore and
Nice.
try an Aiken check. Um,
And we did the
can
Aiken checks, yeah,
no,
last
let's
week.
not. I want to check uh, exactly this. Always
Okay.
succeeds. How do I do that? Do you guys
So,
remember?
oh yeah. So
Yeah, tell me.
you got to use the match dash mat
Dash
m
M.
for
Okay.
match or
Hmm.
dash dash match, and then
Okay.
you give it some uh oh wait a minute, for the validator it's different. So the
It's a, still
test
just a keyword, right?
you can do it by the file name, which would
Okay.
be
What should I type?
wait, normally I just do it by the test.
It
So
doesn't matter like test or file name. So this is a pattern match.
yeah.
It is just
So
matching
just
Pattern
patterns.
try,
match.
It doesn't know if it's a test or a validator or whatever.
yeah, let's just try then always succeeds. Always
Hmm.
underscore succeed. See what
Always
happens.
underscore
Underscore or dash.
succeed underscore. Uh,
Um.
okay, let's try this.
A.
So we have always
Oh.
succeed means always succeed spend. Oh, are our tests also called always succeed spend? Oh,
Yeah, yeah. So
so we
so you really can't run a validator. You have to run a test, I think. See, so it's
hmm.
showing. So see how the little box it says the module, that's the file name, and we can turn off all those
You know what I
warnings
think
stuff.
happened? I
Well,
think I need to save this or something like that. Oh, there it is. Because nothing, it was just passing it. So that means something.
oh, try it
Wait,
again.
what did you
So now,
do?
now, now I think something would have gone wrong. Ah, there it is.
Wait, what did you do? I didn't see
I
that.
just say nothing happened. I just like saved the file after removing the
Oh.
underscore before the datum right here.
Oh, oh, okay, okay, okay.
And
Yeah,
now this is interesting to me because it it didn't fail at the test. It failed when it tried to compile.
exactly.
Um,
Yeah.
right. So, and that's a little bit of like computer science. Like that's what the check runs, like a build step or compile step where it takes everything and makes it into machine code. And if it And if it runs across some syntax error or some other error, it will stop. Um, so it didn't actually get down to a test, which is interesting.
Yep. So it said unused identifier. I'm gonna
Mhm.
put an underscore, Command S to save it, and run it again just to make sure. And it passed again. Okay.
Okay,
So
perfect.
now we know how to use underscore and when to use underscore. Um, Make sense? I'm
Love
moving to
it.
the
Love
next
it.
one. Okay. The underscore. Okay. Tests are included on lines 24 through 36.
Mm,
Okay, cool. So we
mm,
know like there are tests, and tests always start with the keyword test. That's all we need to know at this point. Okay. Step by step, writing, testing, and compiling a validator. Every time you build an application on Cardano, you will build validators. The process of
mhm.
creating a validator is always the same. You must write the validator, test the validator, and finally compile the validator. Then you can use the validator in an application. Okay.
Yep.
As a Cardano developer, this is a process you will follow every time you build a smart contract. In this course, each time we repeat this process, you will learn a bit more about Aiken and Cardano work.
Very nice.
Yes. Step 1, write the validator. In this example, the always succeeds pending validator is provided so that we can focus on step 2 and step 3. You will learn the details of how to write a validator in modules 201 and 203. This comes later.
Mhm.
Test the validator. There are two tests included in always succeeds. We already saw that there are. If you just want to take a look at what they look like, this is how they look. This is one test, and this is the second test. Okay. Um,
Yep.
in lesson 102.3 and 102.3, it's 102.3 and 102.3. Okay. 103.2, I would assume. But anyway, we'll take a closer look at the tests. For now, here is how to run these tests. Aiken check M always succeeds spend. Okay, let's try that. Newman already introduced this. Aiken check
That-
M is
okay.
for match, match the name. Uh, and what is the
Oh,
name of the test? There are two tests here. One is test always succeeds pending. Test always succeed. Oh, sorry, fail
no.
test.
Failed test, yeah.
Yeah, fail always
Wait, what?
succeeds.
M102 test, and
Oh,
then
so
M102 failed test. Okay, okay. Thank you, thank you.
yeah. So if I had to put a name, because I'm trying to figure out how to put a name to separate each of these, but both of them have the exact same thing. So let's see.
But
Let
there's
let me
failed
just
test and
put
there's test.
this. Test always succeed. Fail test always succeed.
Mm-hmm.
Okay. What happens?
Because this the fail part is unique. Otherwise, both the tests have the exact same name. Um, okay. What
What?
happened here? Always succeed spend
Uh,
has passed. The fail test has passed. With the
huh?
trace, the validator crashed prematurely, which is exactly what we wanted, and that is why it passed.
I see. I
Mm.
see. Yeah.
Okay, okay, okay.
That's yeah, testing a fail.
Yeah.
Yeah.
But if I want to test the passing one, how would I do it?
Yeah, just give it the right name, right?
Yeah,
So
I mean, we can't give it the right name because so let me change something up. Test uh
pass.
success. Oh,
Success.
pass.
Yeah.
Pass is a better word. Test pass underscore always succeeds. Okay. Now if I put Pass underscore. Oh, let me save this.
Now you got it, and you gotta do it. Do yeah. Test then pass, not pass then test.
Oh, you're right.
There you go.
So,
Pass. No, yeah,
Underscore pass. Yeah,
yeah.
okay.
that should.
Yes. And
And
now we have
then,
one more to test. Pass always succeeds, and it has passed. Okay. So we have taken
okay,
care of
okay,
that.
yeah, yeah.
So now we know how to match and run tests based on their names. And
Hmm.
this M is just matching their name. Okay.
Yeah.
All right. So we have run those tests. Do you notice how the pattern always succeeds underscore spend also appears in module 103 slash IO mock test? That's okay. Let's look at module 102 to start. In this example, one test passes and the other one fails. This is a good thing. Look at the code. M102 failed test. Can you figure out why the test should fail? Do you want to take a look at the test? Let's take a look at
Yeah,
the
yeah.
test.
Let's say, look, yeah.
Let's go
So
and
why do you
So,
think
arbitrate.
this test should fail? So what is happening in
so
this test? Let's tell me what's going on in this
yeah,
test.
yeah. So it creates a test. It has that weird fail keyword at
Mm-hmm.
the end of it.
Yes.
Then it says the context uh, is a script context with transaction, redeemer, and info. And that is, uh, and then the not always succeed, dot else, and then it passes in this script context. Why?
Can you tell me what is happening here?
Uh,
What is going on here?
so that always succeeds dot else. I don't understand the dot else. It's going all the way to the
So
else.
always succeeds dot spend is this one.
Yeah,
Always succeeds dot else is this one.
yeah. So it doesn't matter what's in. I mean, I don't know. Like I don't know why it adds the context there. Because it's not a spend. Uh, like yeah, okay, yeah. It goes to that else and anything in there
So
and see
what
how it
does the
says the
else take?
underscore. Yeah,
Else
it's
takes something,
anything
but it doesn't matter
optional.
what it takes.
Yeah,
But it has to take something. Say,
yeah,
for example, I'll remove this context, right?
yeah. Try it. That'll be good.
Look at that. You already know there'll be an error.
Interesting. What does it look at the problem or
Problem as
is
in?
in your linter, right?
Oh,
Yeah,
I saw a zero field in a context where there should be one.
yeah. Interesting.
Okay.
Okay. So take everything out of that, just let context equals foo. Like I guess it needs to have a shape of script context. This may be a little bit inside
Oh,
baseball, but
I mean, I don't think so. Does it need to have a shape of a script context?
just do
Uh,
let context
let
equals foo. Yeah, void. There you go.
context is equal to void. Okay. And then we'll put the context here.
Yep.
Okay. See, it took it.
Yeah, nice. Yeah,
Okay,
see
so
if you could just
anything
do
can
it.
go. So that's what this literally means, this underscore right here.
Yeah,
Anything can go.
but it has to be something.
It has to be something. So that's why it said 0 and 1. That means 0 means nothing is there. 1 means something is there.
Right, right. Oh, that's kind of cool. I don't know why you would do that, but why would you hit else? Hit yeah. And then the not. Oh, the not is the fail. So this is like a double negative. So see how we've got the fail and then it succeeds because of that not that exclamation. So if you take that exclamation point off, it's going to pass, I think.
It's just going to be, yeah. So the
It's gonna
test
be
is
it's
going to
gonna be
fail.
pass. Yeah. Well, yes, test
Hmm.
will fail. Yeah, I think because right now it passes as a fail, and it should trace. We could put that trace statement because that's kind of nice to do, like before the online 47, just make a new line and put in the trace. Say this is this will pass if it fails. Whatever. Kind of
Yeah,
silly, but
yeah. So
gets a little crossways.
yeah, yeah, yeah. So if you're putting fail,
Yeah,
that means your this thing should be,
it should fail. You're saying it should fail.
yeah. Well, let me quickly try this. I'm going to remove this fail part
Yeah.
from there. Okay.
Hmm.
And I'm going to run this not pass. I'm gonna run this fail
Hmm.
test.
Yeah, take the whole thing. Yeah, take the whole thing.
I mean, it'll be the same thing.
Okay. Okay. Uh, always succeed spend.
The
Oh, okay.
validators,
No, no, no.
because
That's
yeah,
the name of the validator. Right there is the on the second line. It says M2 fail test always
yeah, yeah.
succeed.
So this is the
Okay.
trace.
So it failed
Yes.
because now let's just keep going down the chain. Take that, yeah, exactly. Take that
Okay.
exclamation off. Do it again, and it should pass. Oh, why did it fail?
Why did it
Because
fail?
oh, because I don't understand why they have that exclamation point in there. Because always succeed dot else. So if it's that also fails. So go up to the validator now, if you don't mind. Well,
Right?
okay. Yeah, yeah, try
Because
that. Try that.
that's what we need to try, right? Like what else
Yeah.
would we have tried?
Uh,
Passed. So even without the exclamation mark, this passed.
yeah. Yeah.
So whether we have the exclamation or not, this is still going to fail.
Yeah, that is weird.
That's
I
what
don't
we
know.
realized.
Yeah, that's like the new thing.
I
Why
wonder
is it
why.
there?
The
So
validator
go.
will, here is my understanding. Oh,
Yeah.
wait a minute. So the validator crashed prematurely. Oh, so the validator crashed. Hmm. If the
Okay,
val
so put the not put the exclamation point back and see if it fails in a different way. Because this
Hmm.
is how it was originally, Lewis.
Yeah,
This
let's
is
see if it
exactly
fails
how it's.
differently. Yeah.
Can you raise up that terminal thing?
The what?
The terminal thing.
I'm
Yeah.
bringing up some. Nice, that's good.
Mm, okay, so now, so when you're putting a fail, okay, let's think this. When you're putting a fail, you want this test to fail or crash, right?
Hmm.
Yeah.
And this exclamation technically always succeeds dot else always gives a fail.
Else always gives a fail.
I mean, at least in this case, it gives a
In
fail.
this case, yeah, yeah, yeah.
Uh,
But it's saying that the validator crashes exit prematurely. You think if it went through that fail, that else and just hit fail, it would just it's not a validator crash.
oh,
You know what
now
I'm
I
saying?
get it. Wait a minute, wait a minute, wait a minute. So this one is not a true or false. It is a fail.
Yeah.
It's a crash. Crash is always false.
Okay.
You
Sure.
know what I'm saying? whether this thing is there or not. That's at least my assumption. So here, so let me change this to false. Okay. Instead of fail, I'm putting false.
Ah, okay, okay.
Okay, now let's see what happens. See, it failed.
Look at that.
Yeah.
That's
And now if you
different.
take this out, this will pass.
Yeah,
See?
beautiful. Nice.
Okay. So whether this exclamation is there or not, the else has to fail and not just be false.
Okay.
Does the keyword fail make sense now?
Yeah. And this is what the docs say in the Aiken language tour under tests. And it says
Let's see.
testing, yeah,
Uh-huh.
testing failures. Um, yeah, no, not any of those. No, not any of
Here,
them.
fail keyword.
Yeah.
Definition. Keyword that immediately halts the validator execution, causing the validator to reject the transaction. Can include an optional message, does not produce a compilation warning. Okay.
Yeah.
Okay. So this makes sense. We use fail whenever we want it to crash, no matter what, just crash. It's not about true or false, it's always false. You cannot ever make it true whenever it fails.
Yeah.
Okay, cool. Think I'm pretty clear up until there.
So
And
that
I'm
was a
gonna
good,
keep.
I think that was a good exploration of the fail keyword because you
Yeah,
you
yeah, I think
sometimes
that's
want
a
to test that it fails. Like failing is what you want it to do. Okay,
exactly,
cool.
exactly. Okay. So, where are we at?
Step three, compile the validator, I believe.
Compile the validator. Once a validator is sufficiently tested, you can compile it. What does it mean to compile a validator? Any guesses? What does it mean to compile a validator, you guys?
This is
Without
a
looking at
computer
this.
science. It's a computer science thing. Yeah.
But
Uh,
what does it mean? What is compiling a validator?
yeah, Lewis, are you don't you're not a computer science guy, but do you know what compile or you have an idea what compile is? And sometimes it's like compile time and run time, and sometimes they say build time. Um, Compile time is like build time. It basically takes and bundles all the code. Sometimes like the code has to go through steps like to make it machine code or I don't know if it always goes to machine code, but it takes it from like the language that we write our code in, and then it turns it into code that the
Something that the
that the
computer can run.
yeah, the computer runs, right? And it's
Yeah,
just made so that it's easy for us to give it instructions,
correct,
So it's our
correct.
instructions, then it sort
Yeah,
of
that's what compiling means in general.
yeah.
But let's see what it means for Aiken. Uh, okay. Aiken is a nice human readable programming language, but Aiken code is not used directly on Cardano. To use a validator on Cardano, it must be converted to byte strings that can be read directly on the blockchain. This conversion process is called compilation.
Yeah.
So everything converts to byte strings.
And this is like week one in computer science. So and this is what we Harsha and I learned. I mean, I guess I don't know. I learned it before, but the CS50 we went into a lot because we were using the C language and that whole
Yep,
like
yep.
that's when I really understood it because each time you had to build out your program and then run it. So it's like this extra step. And a lot of times it's hidden in the interface, but they all compile. And there are
Yeah,
some that languages that are not compiled. For instance, markup languages like Markdown and HTML and CSS, those are not compiled. They just run, they're just used by the services, I believe.
Yeah, yeah.
Okay.
So the process of converting the all of what we have written into the byte string format is called compilation, and byte string format is what the blockchain understands.
Yes, byte string versus this is
Okay.
something
Okay.
with, yeah.
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 What do
So
you,
Makes
what,
sense. Yeah.
if compilation is happening for a regular computer, this is not a byte string. This will be a binary format because computers understand binary. Get what I'm saying?
What? What's that again,
No,
Asha?
yeah,
byte
say that
string.
again.
So byte strings um, are specifically so byte strings are read. So what I'm trying to say is what the blockchain understands is not necessarily what a computer understands.
Okay.
You get what I'm saying?
Mm, yes.
Because a computer understands binary, zeros and ones.
Okay. Blockchain doesn't understand zeros and ones?
Blockchain understands byte strings, which again are converted to zeros and ones eventually, I think. But I think
Right.
the byte string is like the intermediary. That's just my assumption for now.
Yeah, 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 yeah. That is
Uh,
interesting. I mean, Lewis, does that make it clear a little bit? It's just byte string is the thing that the blockchain uses, and that's why Aiken uses it.
yeah,
So
that's why
there's
Aiken
there's
That's
byte
compiles to it.
strings with a Y and byte
Uh-huh.
strings with an I.
I mean,
So byte strings with a Y, and there's byte strings, binary data, and there's binary string, byte string. Oh my days, what have I just stumbled into?
Sure enough.
Binary string, binary strings, or byte strings with an I is in the SQL or PHP. Uh-huh. Yeah.
Mm,
so I think this is just a
Yeah.
byte,
With the
like
yeah,
like a
yeah.
like a bit and a byte, right? A bit is just
Mm,
zero or one. A byte is what? How many is it? Four, right? 4 bits is a byte,
uh,
right? Wait, how many bits is a byte?
or is it eight? It depends on the
Oh, 8 bits, right?
system.
How many bits are in a byte?
Yeah,
8 bits. You're right.
eight
yeah,
eight bits is in a byte. Okay, okay.
yeah.
Yes, a bit is just like a box that either holds a one or a zero, and that means there are 8 boxes available. Okay. Um.
So yeah, yeah, yeah.
Okay, fine. How to compile the always succeeds pending validator?
Is 1 byte. Okay.
Yeah.
Yes. Run Aiken build. This command will generate a file called plutus.json. This file has compiled code for all validators in the course repository. This part we are looking for is the list of validators. Okay. Notice the string compiled code. Okay.
Oh,
Okay. Now
oh, that'll
let's
be
run
fun. Let's do
Aiken
it. Let's
build.
do it. Aiken
Actually, we
build. Yeah.
already did
Yeah.
that, but let's redo it.
Ah,
Aiken
let's do
build.
it again. Yeah, come on now.
Aiken build.
Oh, where did you do the Aiken build? Like which folder? Which you're in the
It's the root,
main
root, root,
root
root.
folder. Oh, and then it put the Plutus.json somewhere, right? Where is it?
Yeah, it's in the root folder.
Okay, good.
So now you see all the
Oh,
validators. Uh, you see, I see an always succeed mint. I need an always succeed spend. Here it is. I have the always succeed spend, and this is the compiled code. This guy.
that's pretty wild, man.
Yeah,
It's a
yeah,
byte
okay.
string. Okay.
Byte strings with a Y.
Yeah. I
Okay.
think that we should take that as a standard, not like the byte strings.
I
Um,
mean, that's a bit string.
so a byte is just like a collection of
Yeah,
bits,
it's like
right? Yeah.
yeah, yeah.
Yeah. And When you
Yeah, yeah,
hash
yeah.
this string, you get this. We use a hashing algorithm to hash the string and you get this. And this is so much more compact, like this thing. It is so much more compact. Um, and that
Yeah.
is why they even hash it in the first place, in my opinion. Does that make
Yeah.
sense? Like why they hashed it? Uh, because the compiled code, look at the size of it. It's pretty big. And that too for such a tiny validator. It literally says true. That's it.
Okay.
And still, it's like pretty huge. But when you hash it, it becomes this. Think of this as like the alias for this, and this can never change. Like even if you change one letter or anything in this, this that means it's not a hash of this compiled code.
Mm.
Does that make
Mm.
sense?
So technically the hash is the validate. Yeah.
Yeah, that's right. Okay, so we have the plutus.json now. Let's see. This file has compiled code for all validators in our course repository. The part we are looking for is the list of validators. Okay, notice the string compiled code. This is the byte string that will be used on the blockchain. Yes, the compiled code will be used on the blockchain, and that is in a format that the blockchain understands. Okay. Learn more. To learn how to build an application that uses a validator like this one, check out other courses. All right. Um, do you want to write a quick success test case? This is the writing the tests are a pretty big lesson. How are you guys feeling? Are you
Oh
guys
no, yeah,
feeling?
we can go on. Yeah, let's keep going.
All right. I can write a success test case for my always succeed validators. Write a success test case. To test a spending validator, we must ask the question, will this validator allow a transaction to spend funds exactly as intended? Always remember, a validator by the end of the day, a spending validator produces an address inside which UTXOs exist. And to spend those UTXOs, this validator provides the logic. Okay? Did that make sense, Newman? Or was it too confusing?
Mm. Wait,
What do you
sorry.
think, Louis?
Spender. Mm.
So it is. I think back on
Mm-hmm, mm-hmm.
when
Yeah,
I
that
looked
makes
on this,
sense.
I'm curious what you
Sorry.
think of it because it, for me, I really like to have the big picture first. Um, and this is sort of like a little part of it, and it's like,
Yeah, so I want you to make sense of this.
yeah,
Will this validator allow a transaction to spend funds exactly as intended?
yeah,
Where is it allowing the funds to be spent from? Where exactly are these funds? Is the first question
yeah.
you have to ask yourself.
That's a great that, and that's what you're doing is you're looking at the context, like the next level up, like the next or the, a step above or beyond it. Like where does a validator live or where does a validator do its action? And this really just became clear to me a couple of, it wasn't always immediately clear. Um, but I will tell you, not keep you in suspense, that the validator is a no, we'll see if I've got it correct.
Yeah,
In
let's
my
see.
mind, in
Mhm.
my mind, the validator basically becomes a wallet. It's the hash becomes an address. Um, so there is and I don't know if you can have multiple validators, yes, at the same script address. But when you publish the validator, you it's not datum, it's an address. I don't know. It's as clear
Always remember,
clear as
Newman,
mud.
a-
Yeah.
all the addresses available already exist. They are just revealed to us.
Okay. All right.
You get what I'm saying? That's what I was talking
Pretty.
about, the namespace. Like all the addresses exist in the in an infinite namespace.
That's pretty spiritual, but yeah, I'll go with it. Okay.
Okay. And when you compile a validator,
Yeah.
the address is revealed to us from the namespace. Okay.
Uh,
And
okay.
so you have, what is this? So you have the compiled code, right? Oh, sorry. You have this thing, right? And you have the hash of the compiled code. You use this to build the address.
Yeah,
Okay.
exactly. And that's my
And the
point. That's
address
my
is
point.
already existing. So that means
Yeah.
we just see the address when we build it, but it already exists in the namespace. Okay. So
Okay, well, that's a
now,
good point. Yeah.
yeah,
But this validator gets hashed. That hash creates a script. That hash creates an address. This
correct.
validator is compiled. Uh, it gets hashed, meaning that it gets sort of standardized, serialized, uh, and then that we use that hash to create a script, to create an address. Um, and then that
Correct.
address becomes a player, becomes available to do all these transactions, and you can send UTXOs to that uh, to that
Address.
address, and you can spend or try to spend UTXOs from that address. And when you try to spend from that address, then that's when the validator comes into action. It says, "Oh,
Exactly.
you're trying to use one of these UTXOs that is assigned to me as a validator hash address." Uh, a lot of it comes down to the terminology. So this this code that we hash becomes an address, and then it becomes available for use on the blockchain. Um, you can send UTXOs to it, and you can spend UTXOs from it. It also does all the other spend purposes, I would imagine, that you can make business logic with those other uh, purposes like minting, governance, et cetera, et cetera.
Exactly. It's like, think of it as a post box, right?
Okay.
Okay.
Anyone can put a letter in it, but only I can pick the letter out because I have the key to the post. Not a post box like the post thing in front of our houses, where
Yeah.
the postman drops like a letter and then we unlock the thing and like get the letter. Uh,
Yeah.
so it's like that.
Mailbox.
Yeah,
Yeah.
a
Mailbox.
mailbox. Yeah. So anyone can drop a letter, in this case, a UTXO, into our mailbox, but only people who have the code, which is the validator logic, can open it or who follow the code.
Yeah. There you
Or,
go.
yeah.
Anybody can
Okay.
drop a letter. Only the owner or special people, only the people with the
Uh,
key
yeah.
can
So in
take
in
it
the
out.
case of yes, that is like all our personal addresses, right?
Yeah.
Uh, but anyone that knows how the validator works, right?
Yeah, yeah. Anyone,
It
not
Yeah.
yeah, because key means like ownership key, or in to use a more clear term in the Aiken space is the pub key hash or the verification key hash. Because it's similar, and this is in these lessons somewhere. I think it's maybe in the next one, which is the one I did last night. That's why I'm thinking about it. So yeah, 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 yeah. I like this. The mailbox metaphor works for me. Lewis, do you get the mailbox metaphor? And it is an important step in kind of getting a mindset of how these things work. You get
Yeah,
the
the
mailbox?
I get the mailbox metaphor. I used to have the same one, but it's a file system. Instead of you see
Okay,
like your keychain, and your keychain has keys. So you use those keys to open the different cabinets on your locker instead of anyway. It
beautiful.
made sense. It makes sense. It makes sense.
Okay, okay, cool. Cool, cool, cool.
All right. Where are we at? The context of the test is a transaction. We must be certain that our code will validate good transactions and invalidate bad ones. Good transactions are the ones that follow the rules of the validator. Bad transactions are the ones that don't. Why can we write tests for a validator? It is possible to write tests for a validator because a validator either validates a transaction by returning true or it doesn't by returning false. We can simulate transactions to test that indeed our validator works as expected. There are
Mm.
two examples of tests in always succeeds spend.ak. So these are the two tests. In these examples, we are using some of the other imports in always succeeds.spend.ak. Okay. In this lesson, we will take a closer look at the first test. Test
Beautiful.
always, so which is, we'll look at the passing test. First test, transaction success case. In the first test, we pass a set of parameters to always succeeds.spend. Okay, let's see what parameters they put. So in this is the one. Um, oh, so always succeeds dot spend. In the test, they called this endpoint. Always succeeds dot spend endpoint they called.
Yeah.
And they gave all the necessary parameters: datum, redeemer, input, and transaction.
Yep.
Okay. None, and this is like the defaults: none, void, mark UTXO reference 00, and placeholder. So it doesn't matter what we give, right? So the default for doesn't matter is these values. So we should know the keywords: none, void, mark UTXO reference, and placeholder. Actually, these are the two keywords that you should know: none and void. Does that make sense?
None and void. Meaning, yeah, like if you want, we could pull up the
You know,
transaction
you know,
placeholder. Yeah.
so if you want to know, the placeholder is simple, like, yeah, I mean, we can go to the transaction placeholder, but these are the important ones
Yeah.
because this
None
we
and
will we will work with anyway. Mark UTXO reference and placeholder. We'll be working with this much more anyway.
well, it always goes in the same order: datum, redeemer, input, transaction. So that's kind of a key thing to learn. So datum is none in this case.
So
Redeemer is
here is what I
void.
want to ask. Why
Okay.
is datum none and why is redeemer void? Why is not datum and redeemer both none or both void?
So I can answer that one.
Yeah, go for it.
Because of the data shape or the schema that's established in the validator. So the datum accepts an option of data.
Mm-hmm.
So that means that so that option takes precedence. It's either some or none.
Mm-hmm.
So we just put none in there.
Mm-hmm.
Um, and then datum or data, and I don't know this for sure, but if I look it up in the standard library, the data is either going to be void or something else.
Zero or
Uh,
something, zero, right? Or
yeah,
something like that. Yeah.
yeah,
But yeah, you're
yeah.
right. That is 100% correct. So
Okay.
empty data is void. But since this is wrapped with option, we can just say none, which serves as the same purpose as void. And the other one is mock UTXO reference. This is just a function that creates a mock UTXO, mock UTXO reference. And the placeholder is a whole transaction, is a placeholder transaction. If you want to look at what a placeholder transaction looks like,
Yeah.
we could always go to the standard library and say placeholder. Placeholder. I thought it will show the whole big. Well, I guess this is it. Transaction placeholder. A placeholder or an empty transaction to serve as a base in transaction building. This is particularly useful for constructing test transactions. Every field is empty or null, and we have in particular this
Yeah.
transaction placeholder ID is this. So this is basically the transaction ID.
Yeah, they're only showing ID and validity range, but there's the whole set of them. Actually, go to transaction, not placeholder. Go to transaction. That'll show you everything in a transaction. There it is,
Yeah,
right
so
there.
everything will be, so all of these sections will be, what did they say? All the sections will be empty or null. So it'll be either an empty list or a null.
But Redeemer is not in the transaction. I guess that's
Why does, yeah, Redeemer is not in the
yeah,
transaction. I mean, the
yeah.
Redeemers are in the transaction, like it'll be added to the transaction by us.
Okay, so do a search here for Redeemer because I'm looking for that data. Like, what is data? Why is data void and not none?
Oh, for that, you'll have to go into something which is a little more low level. You see void here? A
Void.
type
Okay.
of nullinary constructor. See
Nullary
primitive
constructor.
types. Primitive types. Data. One second. Data is an opaque compound type that can represent any possible user-defined type in Aiken. We'll see more about data when we cover custom types. In the meantime, think of data as a kind of wildcard that can
Uh,
possibly represent any serializable value. This is useful when you need to use the values from different types. And when in the case of there is no data, this
yeah.
you use void.
Okay.
So nullinary constructor. Let's see the source. The source will be like some low level void thing. Yeah. Yeah, because that is Rust, and I don't know how to read Rust.
Oh boy.
Um, you have to go back. So okay, we're back to standard library. Okay. Okay. Oh, where were
Hmm.
we at? I forgot.
Uh,
Mm.
we were just at that uh go
Oh,
back to
so
the
we were
lesson, I
giving
think.
like the parameters to always succeed.
Yeah, yeah.
So we gave the four parameters. So first parameter is none. Second parameter is void because it's the data. The third parameter they created like a mock UTXO reference by using, now is the right time Newman, by using the mocktail library
Uh
created by Sedan Labs, and it provides a function called mock UTXO reference. Um, Mocktail Cardano.
yeah. We'll get the library for it.
It's always like a pain in the ass to find
There you go.
mocktail.
Go to vodka. Go, I saw it down there. It's in the
Sedan vodka complete. I can. This is the one.
no. That's the project highlight. Well, this will be it. This will be it.
Yeah, where can
Uh
I find whiskey?
commits and vodka. It's just in their GitHub.
Yeah, so
That's
whiskey
whiskey. Go back
sedan
to
dot.
sit on.
Oh,
That's
whiskey is
whiskey.
different. Oops.
Yeah.
Well,
Yes.
maybe I'll just go to Sedan Labs and find
Yeah.
vodka.
There it
Rum
is right there.
Wait.
vodka. Gin. Okay, Sedan, and this needs to be saved. I'll put it in Aiken.
Yeah.
Oh,
Okay.
they went up in it. Oh, that's your folders.
Yeah, yeah.
Yeah,
Um,
man.
so in
So
this mock,
reference mock UTXO ref. There it is. Oh, there's two of them.
virgin output, okay, I think it's this. Mock UTXO reference. So
Yeah, it
it is
takes
a
two
function,
integers. Yeah.
yeah, that takes two integers and gives out a random output reference. And as soon as keep changing the numbers, this keeps changing. And that's
Nice.
exactly what they did here.
Yeah.
Um, they
Yeah.
created a mock UTXO reference and they gave the numbers 0, 0, and finally the placeholder The empty transaction placeholder is just the placeholder.
Yeah.
And this, if we run this, it succeeds with the trace message at validate for any spending transaction.
Yeah.
That is what we have.
So
Um,
this is, and so it puts out an output reference. Okay, yeah,
yeah,
that's an important part of it. But yeah,
like what,
um,
because this is output reference,
yeah,
right?
yeah. Um, Input, and it needs an output reference. Okay, okay.
All of this is set. Okay. Uh, in the first test, we pass a set of parameters to always succeed.spend. Remember that always succeed.spend is defined like this, and hence we give it all the required parameters. If you want to run it, even if they are not required, even if you see underscores, you still have to give like some values. Even if they're empty values, you still have to give them for this to run. I think that's what they're trying to say. We're passing these parameter values to always succeed. Yes, yes, yes. The
Love it.
type of underscore datum is option datum. Here, the document for option type, we have already seen this. Option can either be some or none. Some basically means there is some value there, none means there's no value there. Because option type is optional, we can provide the none. This is what we have said. Something is there, nothing is there. The type of underscore redeemer is data. Here is an introduction to the data type. Primitive types, we just like saw this. In this
Oh,
example,
okay.
we pass void to underscore redeemer. Void is a type with no value. Learn more about it here. We have seen this as well. The
Okay.
data type can be used to represent any custom type. The data, the data type. I mean, data type and the data type, two
Yeah,
different
yeah,
things. Okay.
yeah.
To develop a Cardano application, you will usually design custom types for datum and redeemer. You will learn more about them in the next coming modules. The
Oh,
type,
yeah.
yeah,
Okay. That's actually pretty good. Yeah. Okay.
yeah,
Like
the type
datum
of,
and redeemer is something that we always do. Like we create those custom types, and those are of type data. Okay, good. All right,
exactly.
that's good.
The type of underscore input is output reference. Output reference is imported from Cardano transaction, Aiken standard library. We have seen that output reference you directly get from the standard library. Output reference. We have seen this so many times, right?
Yeah, 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 yeah. And output, and this, yeah. So output reference in my mind, as it is now, an
Mhm.
output reference is the closest thing that I can say, like what exactly a UTXO is. A UTXO is an output reference, but
No, I disagree with that.
it also has a value. So it's like there's output reference and value, I think. I think those are the
So
two things that
I
make up a
slightly
UTXO.
disagree with that. UTXO is like the bigger, it is everything, it consists of everything. Like, for
Yeah.
example, Newman linear is the output
Me.
reference, but
Okay.
Newman is not just his name, it's also
Yeah.
like everything, all the memories inside his brain, all of the
Yeah.
things he believes in, where he lives,
All right.
like a bunch of things that is encapsulated inside Newman.
I
And
gotcha.
output reference is the just the name of that UTXO.
That's actually a good metaphor because it's the way that my the bodega model the the output reference is sort of a receipt or a name. It's just like this is what we call this collection of it's a former transaction um because it's a hash of a transaction. It's that ID it's just it's a pointer to like a collection of stuff. And that's what that other stuff is like value, and there's a bunch of other little things, datum, uh, there's some other
Correct.
stuff that goes on there. Yeah.
Correct.
Uh,
Yes. Output reference is imported from Cardano. Okay, all of that is fine. The underscore input, we pass the mock UTXO reference, which is what we just discussed. Mock UTXO reference is a function that we used from the Wordka library, which we again just saw. And you just pass in two random numbers and you get a UTXO reference. You get a mock UTXO reference. Uh, and we can do that because we are not really concerned with these values. Any output should be valid in our always succeeds validator. And that is the
Yep.
whole point of giving like a completely random mock UTXO reference. The type of transaction is transaction. Transaction is imported from the Aiken standard library. The type transaction is imported from the Aiken standard library. And we have already seen that a
We just looked
million
at right there.
times,
Right
which
there.
is right. Yeah, oh,
That's
right
it.
here. Yeah.
Right there.
This is the type and this is how it looks. Um, we also import placeholder from the Aiken standard library. And we have just seen placeholder. Placeholder is just this transaction object with like all empty or null values for all of these. Okay. Using this test, remember that Aiken check works with pattern matching. To run only this test, use this command. Aiken check m, all of this.
Yeah.
We'll run it one time, and guess what? It won't run. Will it run? Maybe it
Why not?
will. No, it won't run because I changed the test. For us,
Oh, sneaky, sneaky Harsha.
that's right.
Yeah,
Uh, for this, let's copy this guy.
yeah. Oh, you changed the name of the test.
Yeah, yeah, yeah. Aiken check match with this name, and
Yeah.
the test passed.
And it puts that trace, see that little trace message on line 33 there. Validate for any spending transaction. Yeah, passes.
Yep, that's right.
Beautiful,
That's the
beautiful.
same trace message we have. Where do we have validate for any spending transaction? Right here.
Cool.
All right. I think we
That
have gone
feels,
through all the tests.
yeah. And that feels like a good spot to close down. I'm
Yes.
no need to like try to jump extra stuff. I got a couple of good notes.